Hey everybody, let's give this problem a try. So let's use the method of sections to find the axial forces here, here, and here. So it looks like we should just cut a section right like that. Okay, and then if we pick, I'll just draw both. So the bottom section would look like this. Oh no. This. And then the top section would look like this. Okay, where the axial forces, this would be AC. This one is between B and C. This one is between B and D. Okay, and then the bottom section has, let me pick coordinates. The bottom section has the pin at B here and the roller at A. And I'll decompose the reaction at B into components. And then the top section doesn't have any supports, but it does have the 600-pound load up here. Okay, so given the choice between the top section or the bottom section, there's no wrong choice. But if you pick the bottom section, there are 6 unknowns, so you wouldn't have enough you could only write 3 equations for 6 unknowns. To get the other 3 unknowns, you would need 3 more equations, which to get those 3, you would need to draw the free body diagram of the entire structure, the whole thing. And then for the entire structure, there's a roller at A, a pin at B, and a load up here, 600 pounds. Okay, and then for the entire structure, you can write 3 equations and solve for these 3 unknowns, the reactions, which then you would know these 3. So then for this free body diagram, you'd have 3 more unknowns. Okay, there's nothing wrong with that. But if we just went with this section, it only has 3 unknowns. So then we could just write 3 equations for those 3 unknowns and we'd be done. Okay, let's do that instead. Let's see, we need a little bit of geometry. So this angle I'll call theta, which looks to be the same as here. And theta would be, let's see, tangent is let's see, let me draw the triangle. Oh, let me leave some space. Or the triangle like this. Okay, so this is 4 feet and this is 3 feet. So it's tangent theta is opposite over adjacent. Okay, so then theta would be arctangent of 4/3. So we know the angle. Okay, so back here in the x direction, x is here, negative TAC cosine theta minus TBD cosine theta minus 600 pounds. Is that everything? Yep, equals 0. Okay, y direction, negative TAC sine theta minus TBC minus TBD sine theta. I think we got everything, equals 0. All right, let's sum torque. All right, so let's find somewhere clever. If we sum torque about here, then there's no torque due to either of these 2 forces, either of these 2 unknowns. So I think that's the cleverest. So let's sum torque about, that is point C. Okay, so there's only torque from this. So the lever arm from here to here would be 4 feet, and that makes torque this way, which is in the positive z direction. So that would be positive 4 feet, 600 pounds. Okay, and then there's going to be torque from this force, and to explain it, let me just decompose this force into components. So this component would be TBD cosine. This component would be TBD sine. And now if you look at it, what's the torque about this point due to this force? 0. Right? Only this component produces torque about this point, which would be going this way, which is in the negative z direction. So the torque would be negative, and the lever arm from here to here is 3 feet, and this force here is TBD sine theta, right? And then the torque due to this is nothing. Okay, and I think that's everything, and there we go. The unknowns are here. Okay, so if you look at it, which of these would you like to solve first? I would solve this one first for TBD. Get that number, plug it in right here, and then you can solve for TAC. So now we know both TAC and TBD, so this is the only unknown. So now you know all three. Okay, hopefully that was helpful. So keep on practicing the method of sections, and I'll see you on the next video.